Good afternoon, everybody. We're just going to wait a few minutes while everybody gets on. Okay, so we still have a few people coming on. I'll just do an introduction to the session and let everybody know that the chat function is disabled for this webinar, and all the Q&As will go where the Q&As are, but we will leave that till the end. We'll answer all questions at the end of the presentation, so keep track of what you want to ask. This session is going to examine the irreversible impact of climate change and financial consequences of extreme weather events, which we've all experienced. The session will provide actionable recommendations for reducing physical climate risks, growing costs of climate adaptation projects, and explore critical steps next needed to manage the financial challenges posed by a rapidly changing climate. It's going to be recorded and posted on our MEA website. We'll throw that in as well, and make sure everybody is aware of that near the end of we'll repeat that at the end as well. And my name is Kelly Murphy. I'm the chair of the MEA Climate Change Committee. We have Lisa Babel on, who is the secretary of, and also the co-chair of the Climate Change Committee. And Rashab Sharma is he's the do-all and everything for the MEA Municipal Engineers Association. He does everything for us and makes everything flow well. Catherine is our speaker today, Backhouse. She is Managing Director of Climate Finance and Resilience at the Intact Center on Climate Adaptation. Her work is driving novel insights at the intersection of climate change and finance. Catherine's work includes pioneering research to quantify the impact of flooding on Canada's residential real estate sector and mortgage markets, and developing innovative frameworks to mitigate risk and embed climate preparedness into decision-making for investors. Catherine's work has had national and international influence, informing all levels of government, regulators, supervisors, investors, financial institutions, communities, and homeowners on how to adapt more effectively to a changing climate. Catherine's international efforts focus on regions like Sub-Saharan Africa, Southeast Asia, and South America. She holds an honors Bachelor of Science from the University of Toronto, Masters of Environment and Business degree from the University of Waterloo, and she also holds the Canadian Securities Course certification. She's a TED Talk speaker, 2023 Clean 50 Emerging Leader Award recipient, and chair of the Ontario Biodiversity Council. She also serves on various boards, and I am so excited to have her come and speak to us today. And it's off to the races. There you go, Catherine.
Thanks so much, Kelly. I really appreciate it, and it's a pleasure to be with you all today. As Kelly said, my name is Catherine, and I'm a Managing Director of Finance and Resilience at the Intact Center on Climate Adaptation. Now, for those of you unfamiliar with the Intact Center, we're an applied research center out of the University of Waterloo that helps homeowners, communities, businesses, and governments reduce risks associated with climate change and extreme weather events. So that's particularly in relation to flooding, wildfire, and extreme heat, as you can see from the photos here. Climate change manifests itself as extreme weather, and these events are becoming more severe around the world. Last year alone, we saw the largest losses due to extreme weather in Canadian history. We saw devastating flooding in Montreal and Toronto, the largest hailstorm ever in Calgary, Alberta, and of course, the Jasper wildfire. These events caused power outages, supply chain impacts, evacuations, socioeconomic implications, and sadly, loss of life. And so that's what I'm here to focus on today. Next slide, please. So by way of agenda, we're going to head into the following direction. We're going to discuss the science of climate change and how it's effectively irreversible. We're going to discuss the costs of physical climate change and extreme weather. And then we're going to turn to guidance available to limit the physical risks of climate change and extreme weather. So standards and guidelines have already been developed to improve the resiliency of Canada to a changing climate. but they're just being deployed too slowly. So what this presentation is going to do is it's going to showcase Canada's urgent need to adapt and how municipal engineers, as those who focus on infrastructure planning and development, public works and maintenance, emergency and disaster management, and much more, how you all are in a great position to help. And finally, I'm going to give a great example of adaptation, the cost effectiveness of these types of strategies, and tools available to help identify and reduce risks. So with that, and since we have a lot of ground to cover in a short amount of time, and we of course want to leave time for questions at the end, let's get right to it. Next slide, please. So we know, according to authoritative bodies such as the Intergovernmental Panel on Climate Change and Environment and Climate Change Canada, so the first two reports on the left-hand side of your screen, climate change is real. It has happened, it is happening, and it will continue to happen. So a certain degree of climate change, it's already baked into the system, and therefore it is in fact irreversible. So we can slow down the rate of change, but we cannot reverse it, at least not with the technology that we currently have. And of course, we understand that the leading cause of this change is the burning of fossil fuels. So people will often say to me, well, Catherine, climate change has happened in the past, and I would agree with them. It has. But reasons for previous changing climate events, such as the tilting of the Earth's axis, radiation from the sun, volcanic eruptions, an asteroid, cannot explain the change in climate that is occurring right now. Now, there are natural fluctuations and variations within the Earth's atmosphere, but the leading cause of this change is the burning of fossil fuels, natural gas, coal, and oil, that when burnt release greenhouse gas emissions that trap and concentrate energy in the envelope of the Earth's atmosphere that would have otherwise escaped into space. This causes warming and the manifestation of extreme weather, extreme heat, drought, wildfires, flooding. And so the global consensus is that greenhouse gas emissions must fall. Yet, according to the United Nations Environment Program, their emissions gap report of 2024, the report in the top right-hand corner of your screen, finds that international commitments to the Paris Agreement are falling short, and there are currently no credible pathways to keep temperatures below 1.5 degrees Celsius and achieve global net zero. So strategies to mitigate against greenhouse gas emissions, they're imperative and they have to continue. We have to continue to put resources, time, and money towards those initiatives, because that's going to avoid the worst impacts of climate change in the future. But we have to acknowledge that the severe impacts of climate change, they're already present today, and they're going to continue to be present into the future. And so adaptation, building resilience at the level of our homes, communities, and across our businesses must also be an important part of the climate change discussion. And yet, we also know from the United Nations Environment Program, their adaptation gap report of 2024, the bottom right-hand corner of your screen, that adaptation financing, planning, and implementation are all plateauing. We are not putting enough resources towards adaptation. And yet we also know that for every dollar that we put into place for adaptation, that's going to save us, on average, $2 to $10 in cost avoidance over a 10-year period. So climate adaptation is the cost-effective strategy. And without adaptation, extreme weather events are going to continue to be negatively impactful. And since we understand it's the burning of fossil fuels that has driven these more intense storms, then the expression of climate change as extreme weather, that's going to continue to further worsen with the burning of fossil fuels. So the question is, well, are we going to continue to burn fossil fuels? Next slide, please. So as you can see from the graph on the left, globally, we've been emitting greater amounts of CO2, carbon dioxide, into the atmosphere year over year. Now, I actually really like this graph because it really shows science at play. So those slight fluctuations or dips that you see on the graph, it's actually due to times of photosynthesis, where trees and plants absorb CO2 and release oxygen into the atmosphere. Now, this graph ends in the middle of 2023. I apologize, I couldn't find an updated version for 2024, but we know the numbers. So 2023, we reached 424 parts per million of carbon dioxide. In 2024, we reached 426 parts per million. So we are continuing to go up. But what are future projections of CO2 and other greenhouse gas emissions in the atmosphere? Well, we know, according to the International Energy Agency, which is the global authority on global energy use, the World Energy Outlook and other organizations, 80% of the world's energy supply currently comes from a third, oil, coal, natural gas, three fossil-based resources that when burnt release greenhouse gas emissions into the atmosphere, increasing the impacts of climate change. So by 2040, it's estimated that approximately 70 to 75% of the world's energy supply will continue to come from a third, oil, coal, natural gas, but global energy output will actually be 12 to 15% higher, with two key reasons. One, population growth. So hourly, we add an additional 8,000 people to this planet if you subtract births from deaths. Per year, that's around 70 million people. So by approximately 2040, we're going to have an additional 1 billion people on this planet who deserve access to clean water, electricity, education, and healthcare, which all drives up emissions. Now, there is a body of research that says by 2040, population growth is going to drastically slow and or reverse, so population decline, which personally I do actually agree with based on the age dynamics within certain countries. There are countries around the world that have more people living in their 90s than their 80s, 70s, 60s, 50s, 40s, so inverse triangle. But for the next 10 to 15 years, the Earth's carrying capacity is going to continue to be exceeded and energy output will continue to increase. And that means we're going to continue to emit greenhouse gas emissions. Now, in addition to population growth, we have geopolitical issues that are a driving factor in fossil fuel use. So we can actually look to the war in Ukraine as an example of this. So the war is forcing countries to take from oil reserves and even consider reigniting coal-fired plants to substitute for loss of energy supplies from countries like Russia. So just to give you a little bit of context, coal burns at 100% higher carbon intensity per unit of energy than natural gas. So by reigniting coal-fired plants, we're putting more greenhouse gas emissions into the atmosphere with the use of coal. So the chart on the left, it's going to continue to increase. Now, what happens if we flip the switch tomorrow and stopped burning fossil fuels on the planet? Well, there's actually currently natural processes in place that will continue to drive the impacts of climate change. So if you take a look at the image on the right hand side of your screen, there are mechanisms called positive feedback loops also contribute to the increasing impacts of climate change. So just as an example, as temperatures continue to rise, ice and snow cover will continue to melt. Ice and snow cover, that white color, it reflects the sun and its heat away from the Earth's surface. But when that ice and snow melts, dark surfaces, such as bodies of water, absorb that heat, contributing to rising temperatures, which then melts more ice and snow, which then contributes to rising temperatures, which then you get the idea of the positive feedback loop. So even if we continue to put efforts towards reducing greenhouse gas emissions, which we need to do again to limit the worst impacts of climate change in the future, these mechanisms such as positive feedback loops, that's just going to continue to increase the manifestation of climate change as extreme weather. Next slide, please. So as the air and water continues to warm, what does that mean over the medium and long term? So what we can expect is more extremes and more variability between hot, dry, and no rain conditions and heavy extreme rainfall and storm surges. So hotter temperatures, this is going to lead to drought-like conditions that dry out natural spaces such as soils, grasslands, and forested areas, increasing the risk of wildfire. With higher temperatures, which increases more moisture in the system, and with more moisture, this actually leads to more lightning storms. Lightning storms are the cause of 50% of all wildfires from igniting. The other 50% is human caused. Now, interesting here though, the 50% caused by lightning storms causes 80% of the land being burned during a wildfire. So we can control for that 50% human caused, but that's only going to protect approximately 20% of the land. Now, in regards to precipitation and flooding, rising temperatures lead to greater amounts of precipitation falling because warm air holds more moisture. So if you have more moisture and more energy in the system, when water condenses and comes down in the form of precipitation, we end up with bigger storms, with more water coming down over shorter periods of time. And the energy that went into evaporating that water in the first place, it doesn't disappear, it stays in the system. So storms are coming down with even greater force than ever before. And with rising temperatures, this is also going to lead to back-to-back devastating hurricanes. So hurricanes form over warm oceans, and they're characterized by strong winds, heavy rainfall, and rotating systems. They become more intense due to climate change because of hotter oceans, because of those natural processes we were just talking about, which provide the energies hurricanes need to be able to develop. Warmer waters cause more evaporation, adding moisture to the atmosphere, strengthening storms and rainfall. And we're also seeing rising sea levels from melting ice caps. It actually makes the storm surges during hurricanes even worse. So higher temperatures and more water in the system make these storms, which are already dangerous, even more powerful and destructive. In my opinion, I think we're going to see a recategorization of hurricanes to include Category 6 hurricanes going forward. So we understand the impacts of climate change are going to continue to increase and manifest as extreme weather. And we're not putting enough resources towards adaptation. So then the costs associated with extreme weather, those are going to increase as well. So the question is, what are the costs of extreme weather? Next slide, please. So there is no better witness than the cost of climate change and extreme weather than the property and casualty insurance sector, the P&C insurance sector. And I don't want to bore you. This is not to talk about insurance. Insurance is actually just they're very good at calculating losses associated with extreme weather, as you can see from this graph here. So for those of you unfamiliar, this image displays the annual catastrophic insurable losses for Canada. So cat loss is any event, flood, wildfire, hailstorm, windstorm, that triggers $30 million or more of insured losses. So just to orientate everyone on the graph, on your x-axis, you have years. Cat losses in Canada started to be calculated in 1983. Along your y-axis, you have billions of dollars worth of losses. So between 1983, which is the start of the graph, to 2008, losses range from approximately $400 to $700 million per year for extreme weather events. So that's what all insurance companies in Canada would pay out of pocket for. As you can see from 2009 onward, which is within that gray box region, there's this discernible upward trend in losses. So losses now average approximately $2.8 billion per year. And last year, 2024, it was the worst loss year in Canadian history at $8.5 billion. Now, just in case you're wondering, these losses are corrected for inflation and per capita wealth accumulation. So we are looking at a comparison of apples to apples. And it's also important to note these are insurable losses. But what are the costs that insurance don't cover and come out of the pockets of individuals, as an example? Well, the rule of thumb here in Canada is multiply these amounts by 3 to 4 times, and then you get uninsured losses. So let's take 2024, 8.5 billion. Well, that would equate to 24 to 32 billion dollars coming out of the pockets of individuals, businesses, and governments. For governments such as municipalities, that's money coming out of budgets for hospitals, schools, infrastructure development. For businesses, that's money coming out of budgets for business expansion, equipment upgrades, employee compensation. And so we have to start thinking about this as an opportunity cost that's being lost because adaptation has not been adopted. Now, it's also important to note that the upward trend of this graph, it's not solely due to climate change. Of course, climate change is a driver within that system, but you have compounding factors, which is where municipal engineers could actually really come into play. So one, you have aging municipal infrastructure. 2, infrastructure that never incorporated adaptation into decision-making, and the loss of natural infrastructure, wetlands, grasslands, and forested areas due to development. So understanding how to build homes and communities and how to retrofit existing homes and communities is an important step in reducing risks and costs in the system, and possibly a role municipal engineers can play in understanding what measures need to be taken to get risk out of the system. Now, I really like this graph because you can actually isolate for the different types of extreme weather events. So year over year, we can determine, okay, well, where were the most costs coming out of? So just as an example, in 2016, you had the Fort McMurray wildfire dominated that year of losses. But year over year, flooding is actually the costliest extreme weather event across Canada. So I want to focus that this is not just to talk about the financial impacts to insurance. Insurance is a very good proxy for the growing risk in the system. But if insurance is being hit, most, if not all, other industry sectors within communities are also being impacted to some degree. But if we just focus on insurance and flooding for a second, and again, how are our municipalities being impacted? How are individuals and businesses being impacted? So we know from the Insurance Bureau of Canada that 10% of the Canadian housing market, approximately 1.5 million homes, are now uninsurable for flood risk. You cannot get insurance for any type of flooding at the level of your home. So that's flooding, mostly translating itself as flooded basements. So remember, we're talking from an insurable perspective here. When we talk about flooding from an uninsurable perspective, that would be major costs coming out for infrastructure, buildings, roads, and bridges. But if we just go back to the insurable costs for a second, a flooded basement in Canada costs on average $54,000. There's usually a cap in insurance for about $10,000 to $20,000. So think about the implications to a homeowner. If their home isn't properly prepared for a flood event, they could be on the line for $44,000 if their basement floods out. And on average, it's usually because sewage water is backed up into the home, and you need to get that sewer water out of your home within 2 days or the house is uninhabitable. And we also can layer on that last year in Quebec, Desjardins Financial stopped offering mortgages in certain regions. So now those homes are at risk of becoming stranded assets because they're in such great flood risk. And we're seeing this throughout the United States and globally as well, and not just in regards to flooding, but in regards to wildfire as well. So it's happening in Quebec. I could guarantee that's probably going to start happening across Canada as well. So what we're seeing is these cascading and eroding effects throughout our economy. And it's not just the uninsurability, but also stability of housing markets. Next slide, please. So this is where the Intact Centre report, Treading Water, Impact of Catastrophic Flooding on Canada's Housing Market, really comes into play. So this was the first ever quantitative analysis in Canada looking at the impact flooding has on the Canadian housing market. So the purpose of this report was to determine if community level flooding has an impact on the average sold price of a house, the number of homes on the market, the number of days on the market, and mortgage arrears and deferrals. So this slide highlights the results quite well, but in short, homes located in flooded communities. Now listen to my wording there. Homes located in flooded communities. The home did not need to be flooded out. It only needed to be stigmatized by the community that was flooded out. So homes located in flooded communities compared to their non-flooded counterparts, and we were able to control for the experiment, experienced an 8.2% reduction in the sold price of their homes. 44% less homes were listed on the market in flooded communities. And when homes were listed on the market, they stayed there 20% longer. And when we investigated the impact on mortgages, there was an impact to loan to value ratio. Now, why is any of this important to you as municipal engineers? Well, the devaluation of a residential property, that's mostly important to a mortgage provider and insurer. But if you think about it from the municipal level, if there is no insurance in place, or worse, no mortgages available, then that area of homes, one, has the potential to become stranded assets. And then the municipality actually has people moving away from those locations. How do municipalities make money? It's through their tax base. So municipalities need to ensure resilience of communities to ensure stability within the housing market so that people can get insurance and mortgages to be able to buy and sell their homes. So all of this is intertwined with one another. And if you think it's outside of your purview, I think it's just another argument for why resilience is so incredibly important. And so to minimize the risk against a backdrop of escalating extreme weather risk, municipalities actually need to understand where there is risk in the system and then deploy resources and to homeowners, and then codes and standards for engineers and builders to follow when building and retrofitting homes and communities. Next slide, please. But how prepared is Canada for extreme weather risk, and where can improvements be made? Do we even have that information across Canada? Well, in regards to flooding, we actually do. So in 2020, the Intact Centre examined the preparedness of provincial and territorial governments to minimize the negative consequences of current and future floods. So this report here, it provided a holistic picture of how provincial and territorial governments self-assessed their flood readiness efforts relative to 4 pillars of emergency management: mitigation, preparedness, response, and recovery. So for municipal engineers who are involved with emergency and disaster management, this report could actually be of interest to you. And I'm going to dive into some of our research even further, but please know any report that I mentioned here is freely available on the Intact Centre website. So if you're interested to learn more, please go to our website. I'm happy to work with Kelly afterwards to provide some links under separate cover as well. So based on a set of criteria, what we did was we actually graded each province and territory with a letter grade, A to E, A being the highest grade, E being the lowest. So the Canadian average score was actually a C, with the highest score being a B minus and the lowest score being a C minus. So no one was really good and no one was really bad. But why is understanding how prepared provinces and territories are, why is that important for municipalities? Well, we can actually look to Nova Scotia's flood preparedness to really help us answer that question. So in 2020, Nova Scotia received the average Canadian grade of a C. It fell behind the average compared to its peers on all criteria except one. So they fell behind on floodplain mapping, flood risk assessments, land use planning, waterway management, sustainable flood management, new development projects, and emergency management and critical infrastructure assessment. And it's that emergency management and critical infrastructure assessments that I just want to focus on really quickly here. So fast forward now to 2023. In 2023, Nova Scotia experienced multiple municipalities across Nova Scotia experienced over 200 millimeters of rain falling in about 3 to 4 hours. And that's a lot of rain falling over short periods of time. You had roads and bridges flood out. You had culverts, so those subterranean waterways that direct water around obstacles, bridges, and roads. Culverts were collapsing. And so what you saw were 2 different types of incidents happening. So let's just focus on the financial impact first. So first you had CN Rail. So CN Rail, it's the only port out of Nova Scotia. And there's a joint effort between the province and CN Rail to maintain the rail in and out of the province. Well, neither had properly maintained it. High precipitation event occurs, culverts collapsed, the rail collapsed, and basically business operations were impacted for over 2 weeks. Now, for a municipality that does not understand where faults exist in the system and fails to conduct critical infrastructure assessments, the consequences can be severe. And that's not just financially, but in terms of public safety as well. And so this is where emergency management comes into play. So during that flood event, emergency alert systems weren't activated in time. And tragically, that resulted in 4 people losing their lives. And fast forward to 2024, a teenager also lost their lives again because there was no notification to get people out of harm's way or to stay in their homes. So as municipal engineers, how do you identify risks within the system and then effectively communicate the necessary actions to mitigate against them? And so we know there's growing risk in the system, but what do we do about it? Next slide, please. So at this point in my presentations, I always like to thank everyone for bearing with me because I know the first few slides can be incredibly depressing. You know, the news nowadays, it's already quite dark times. So what I always like to do in my presentations is really bring out some good news. And there is some good news, lots of good news actually, here in Canada in regards to adapting to those key physical climate risks. So standards, guidelines, and tools, they're already available to reduce the risk of flooding, wildfire, and extreme heat. So flooding and wildfire, those are your costliest from a financial perspective. Extreme heat is the costliest from a loss of life perspective, and I'll talk about that a little bit later. Now, for each of the reports and tools you see here, our team at the Intact Centre, we've worked with standard setting bodies such as the Canadian Standards Association, Standards Council of Canada, the National Research Council, as well as each one of our reports, we work with 50 to 200 subject matter experts. So whether these are engineers, environmentalists, conservation authorities, working directly with the municipalities, builders, developers, to be able to offer feedback on what are actual practical, meaningful, and cost-effective ways to adapt to the physical risks of climate change. So on this slide here, what I've done is I've provided guidelines and tools to reduce the risk of flooding at the level of the home, community, new and existing community design, and coastal communities. So how should we be building and retrofitting homes and communities to reduce flood risk? And the good news, again, is we have that information. We don't have to start from scratch. Commercial real estate. How do we build and retrofit commercial buildings and commercial assets? And the importance of retaining and restoring natural infrastructure, wetlands, grasslands, and forested areas to attenuate the effects of flooding. So how can we incorporate natural infrastructure into community design? In regards to wildfire, the Intact Centre has worked with Fire Smart Canada, the wildfire protection experts in Canada. So we were lucky to work with them and develop wildfire protection measures for the level of the home and community. So again, how should homes be built and retrofitted to reduce wildfire risk? And the Intact Centre, we've also investigated the impact of extreme heat on infrastructure and services, the economy, natural systems, and community health, and what action should be taken from a behavioral, natural infrastructure, and gray infrastructure solutions perspective. So a gray infrastructure solution would be the importance of power backup generation. So as municipal engineers, when thinking about homes, community, and infrastructure development, what measures are we thinking about to reduce the risk of flooding, wildfire, and extreme heat? So what we recognize at the Intact Centre is that people don't like to read reports, or at least most people don't. They like to know the research has been done, but most people don't have the time or the patience to read through a 50 or 100-page document, even though we summarize it in a really nice executive summary. Now, I have two engineers in my family. My father's a mechanical engineer, my brother's an aerospace engineer. So I know probably municipal engineers, you probably want to get into more of that technical detail, which is great. So again, please know the resources are freely available for you to dive in more, and I'm always happy to answer any questions. But really, let's offer, just for our conversation today, what's kind of that high level overview of what we need to be considering. And so our team has taken all of the great knowledge that we found within these reports, and then we actually distilled them down into one-page infographics to be able to help easily communicate what measures need to be taken to reduce risks. A lot of these have been geared towards a homeowner. How can we actually get these into individuals' hands? But again, if we're talking about very high level actions around homes and in communities, let's just use these as really good visuals for today. So next slide, please. So let's start with flooding, which is again, the costliest extreme weather event in Canada. And we can actually start isolating for where those costs are. We know it's at the level of the home and community. So we took the findings of all of those reports in regards to flooding that you saw on the previous slide, and then we were able to distill it down into these one-page infographics, one for home and one for community. So let's focus on the home for a second. So the key findings that assisted in the creation of this 3 steps to cost-effective home flood protection infographic, which basically drills down around characteristics around and inside a home that when precipitation events occur could impact the probability that a home is flooded. So again, this is geared more towards an individual, but I'm sure many of you own your own homes. So let's just focus on the individual right now. So the infographic provides 15 key actions that any homeowner can take to reduce their risk of basement flooding. What you can see is we've broken it out based on cost, and we have more detailed information if you're looking for what actual costs of other instruments are. I have that information if you'd like to, please just follow up with me. But basically we broke it up based on cost. What can I do for $0, under $250, and over $250? So actions include cleaning out east troughs, installing window well coverings, installing sump pumps and backwater valves, and then checking your sump pumps and backwater valves. And your sump pumps and backwater valves, these are devices that stop water from coming in the home and get water out of the home if there is water in the home. So what are a few of these actions that you could take into consideration? Well, when designing new homes or designing and building new homes, how are we taking things like sump pumps and backwater valves into consideration? I'd also say sump pumps and backwater valves, they're already coded to be included into homes. So every home, any new home construction in Canada should include these devices. For new homes, we have to keep in mind, and when we're developing communities, it is more cost effective to build correctly and include adaptation than retrofit later on. So just as an example, your sump pumps and your backwater valves in a home could cost anywhere between $1,000 to $4,000 per device. When you implement them at construction, at point of construction, they're a few $100s. So just, it's a simple example, but again, the costs are much lower when we implement them at building, the point of building. Now at the community level, and probably something you're more interested in, how are we engaging? How are communities engaging with individuals and commercial property owners? So how is the community deploying information such as home flood protection infographics through property tax mail-out notices and social media campaigns? Again, we have to get this knowledge into the communities. If we're focusing on emergency management, we need to prepare rather than respond. Of course, we need to respond, but we need to prepare much better. What about flood risk management practices at the municipal level? What are we putting into place? How are we as a community identifying where there's risk in the system? Do we have vulnerable communities? Do they need more resources? And what emergency plans do we have in place? And at the watershed scale and shoreline scales, what management practices are being engaged? So are we thinking, when we're planning for our community design, are we just thinking about our community, or are we working with nearby communities? Do we understand the flow of water, that the flow dynamics of water will change the moment that we build a home? This changes. Are we working with the communities nearby to be able to understand, hey, how are actions you're taking going to affect us? Are we retaining and restoring natural infrastructure? And then ultimately, could we potentially be getting people out of harm's way? Should we be building here? And if we've already built here, do we need to get people out of harm's way? So again, more information is available throughout our reports, but again, these infographics just offer kind of some of that high level checklists. Now, moving to more commercial end of things. Thank you. Next slide. Flood resilience guidance for commercial real estate has already been developed for Canada, including 20 practical actions to help businesses get their property portfolios climate ready, which was detailed in this report on the left-hand side of your screen ahead of the storm. Now, our team at the Intact Centre, we took the findings of this report and we distilled it down into a one-page infographic. So the actions listed here highlight the key areas that we should be thinking about. What are we doing from plans and procedures, equipment and supplies, and major retrofits, as well as what to do during and after a major flood event. Now, this is for a building that's already been built. And so it's those major retrofits that we should be thinking about for commercial infrastructure, and what measures need to be implemented at the time of construction or during the retrofitting process. So similar as I detailed on the community infographic, the commercial real estate infographic, it could be used by municipalities to engage with public and private commercial owners and operators so that they understand their risk, but also as assets are being built, what considerations are we thinking about? So again, the full guidance, everything is freely available online. Next slide, please. So flooding, the most costly. Wildfire, second most costly. So for construction and development, businesses and individuals located in the wildland urban interface. So this is where human development meets wildland vegetation. There's a wealth of wildfire resilience information available through Fire Smart Canada. If you're unfamiliar with Fire Smart Canada, they're a national organization. They are the wildfire experts. They have over 20 years of experience in Canada helping get risk out of the system in regards to wildfire. So in addition to Fire Smart Canada, the Intact Centre produced this report, Wildfire Ready, Practical Guidance to Strengthen the Resilience of Canadian Homes and Communities. And it offers practical guidance to help individuals, municipalities, municipal engineers understand where there is risk in the system and what steps need to be taken to strengthen home and community resilience in locations facing the growing threat of wildfire. Now, let me give you a few statistics here because this is really interesting. But we know that an estimated 60% of Canadian communities are vulnerable to damage and disruptions due to wildfire because of their proximity to these fire-prone natural ecosystems. So any communities located near forests and grasslands. And this risk is actually escalating. So again, where are we building our communities, or how are we retrofitting our communities to reduce this risk? Well, we're expanding urban and industrial development into these areas. We have a lack of nationally accepted minimum building standards to safeguard against wildfire risk. And what we've done over the last 100 years is we've actually participated in fire suppression. So we've allowed for highly flammable vegetation, this fuels. It's basically dried leaves, and all that basically creates a kindling that when wildfire starts, it just adds fuel to the flame, basically. And so we need to take Western science and Indigenous knowledge, and we need to participate in what's called prescribed burning. The window for prescribed burns throughout the year is shrinking because of climate change. And so we don't obviously want to do a prescribed burn and then start a wildfire. So it's a very particular time and way that you can do these things, but we need to start doing that more and more. And of course, then climate change is then compounding all of these factors. So very similar to our other reports, we took the findings and we distilled it down into these two infographics, one for the level of the home, one for the level of the community. So what you'll notice is very similar to the home flood protection. In the wildfire protection, we broke it up based at the level of the home. We broke it up based on cost. So for a homeowner, what are the costs associated with making their homes more resilient? What you'll notice though is the cost associated with wildfire resilience is very different than flood. Flood was $0, $250, and over 250, probably maxing out at a few thousand. Wildfire, 0 to 300, 300 to 3,000, and 3,000 to 30,000. Now 30,000, you're starting to get in the metal roof territory, and you don't need a metal roof, you just need fire resistant materials, which I'll get to shortly. But why is there a difference in cost? One, it is the materials that are required themselves, but the risk in the system is also very different. So if you are an engineer operating within a municipality that deals with flood risk, wildfire, or both, the flood risk, again, on average, usually manifests as flooded basements. Homes aren't usually being washed away. In regards to wildfire risk, costs are so great because we're usually dealing with catastrophic loss of the home. The home usually completely burns down. And so there's different costs in the system associated with that. But again, similar to flooding, building right the first time in regards to wildfire resilience, it is the more cost-effective strategy. So I don't want to go into too much detail here. Again, happy for you to review this on your own and ask any questions. But just really quickly, I want to offer two steps. One action is not an engineered solution. It's basically a best practice, but moving combustible material, firewood plants and trees 10 meters from the home, and putting Class A fire resistant siding and roofing. So you don't need a metal roof, you just need Class A fire resistant siding and roofing. It looks like asphalt shingles, but it's fire resistive. Same cost as asphalt shingles, by the way. Those two actions alone will help reduce the home burning down by 50 to 75%. So even the kind of the best practice of moving combustible material when building homes and communities, how are we placing plants and trees in relationship to homes? These should all be things we're taking into consideration. Now, probably more specifically for municipal engineers, what are we doing at the community level? So how are we building structures? Are we using fire resistant materials? Again, that Class A fire resistant siding. Homes should actually be built further apart. Most ignitions deal with embers that travel dozens of kilometers, or can travel dozens of kilometers, land on people's roofs, and if there's not fire resistant roofing or siding, that home will tend to ignite. If that home ignites, there is opportunity for it to spread to the next home. If we space out our homes further, that limits the spread of wildfire between homes. When we look at infrastructure within our communities, power lines as an example, we need to ensure vegetation, tree branches are removed 5 meters from those lines to reduce the probability of arcing. And where feasible, obviously supply lines should be built underground. I understand this is highly cost prohibitive, but again, if we're designing communities, does it actually make more sense to build underground in the first place? I fully respect that's an incredibly expensive thing to do. We need fire zones or fire breaks. So we need a 30-meter break featuring ignition resistant material. We need to be mowing grasses, putting in ponds or roads so that we can limit the spread of the wildfire into the community. And again, non-engineered solutions, we need to make sure there's emergency shelters, firefighters complete training once a year, and minimum water supply is incredibly important. So these are just a few of the examples. And again, there's a lot more when building and retrofitting in the wildland urban interface, but again, just gives you something to consider. Next slide, please. So we focused a lot on floods and wildfires, again, from a financial perspective. Yet people tend to not die, or the numbers are very low. And that's really not to sound indelicate, because of course we had the 4 people in Nova Scotia pass away in 2022 in the wildfires. There was a dozen people who passed away. So of course I recognize people do or can die due to floods and wildfires, but our emergency alert systems are fairly good in that response. In regards to extreme heat, there is no reprieve. There is nowhere to go. And so extreme heat events, they're consistently deadly for people. So in Quebec in 2018, 86 people passed away. In the heat dome in British Columbia, 619 people died. And just for scale, in Europe in 2022, 60,000 people died due to extreme heat. And so we have to be increasingly aware that urban areas in particular will be increasingly more at risk due to extreme heat events. And that's specifically due to what's known as the urban heat island effect. So this is where urban areas, paved over spaces, absorb heat from the sun and then contribute 10 to 15 degree higher temperatures than surrounding non-urban rural areas. And so again, municipal engineers, from your perspective, how are we building urban areas to take into consideration things like the urban heat island effect? So specific actions for individuals, municipalities, businesses, property owners, and managers were identified in this national guidance document. Irreversible extreme heat, protecting Canadians and communities from a lethal future. So our team investigated the impact of extreme heat and what it has on the economy, natural systems, the community health. And so the report sets out actions. What should we be doing from a non-structural perspective? Behavioral solutions. Does the community have, how are we checking on our most vulnerable, basically? What about natural infrastructure solutions, retaining and restoring natural infrastructure or rebuilding that natural infrastructure that we've ripped up and put cement down for? And for building owners and operators, we need to focus on built infrastructure solutions, specifically passive and active of cooling buildings. And we need to focus on provisions for backup power generation during potential power outages. Now, I want to be respectful of time. I have 2 more slides before we can go to questions, but I just want to give you an interesting statistic here. So this comes from the former Chief Resiliency Officer of Toronto. We currently have 500,000 people living in apartment buildings that are 30 years of age or older, that are over 8 stories high, and 1/3 of them do not have enough power backup generation to run one elevator more than 1 to 2 hours. And so think about if you have an elderly person, someone with a pre-existing health condition, a pregnant woman, someone living on a higher floor that maybe is unable to access the stairs. During a power outage, obviously the elevators won't be working, fans and air conditioning units won't be working, and municipal flow of water, the pressure doesn't go over the 6th floor, so they won't have access to water. So again, when we're thinking about building and design, we need to be taking these things into consideration and specifically thinking about our most vulnerable. Next slide, please. So I've talked about a lot of actions. Again, how do we engage with individuals? How should we be thinking about this stuff at the level of the community? But what is the actual cost of major infrastructure projects? And as municipal engineers, I'm sure you're all very well aware, these are very costly projects. But what is the cost effectiveness of them? So a really great example of this would be the Don River and Central Waterfront project in Toronto. So for those of you unfamiliar, this is the largest stormwater management initiative in the city's history. So when Toronto experiences high precipitation events, because of its aging infrastructure, it has sewage and rainwater piping systems running through the same system. Therefore, when we experience high precipitation events like what Toronto experienced last July, this leads to what's called combined sewer overflow. So the rainwater basically pushes sewage throughout those systems, and that sewage ends up in people's basements, on roadways like the Don Valley Parkway, and then it pollutes waterways as well. So the intention of this project is to be able to hold, and you can see from the photos here, it's in a very impressive tunnel system, and it's going to hold 650,000 cubic meters of water during these high precipitation events. Now, once the water recedes from water bodies and sewer systems, the water is going to be sanitized and then slowly released out of these tunnel systems into waterways. So the idea is, let's reduce flood risk in Toronto. So initially, this project was budgeted at $2.5 billion. It's now projected at $3.7 billion. Obviously, costs have escalated, high inflation, supply chain issues, staffing difficulties. There's still 10 to 15 years left to go. We're obviously going through a trade war right now. Inflation will probably go back up. So my assumption is this budget is going to continue to grow over the next 10 to 15 years. I put it closer to 5 billion, if not over that, but let's use 5 billion for this example. So major infrastructure projects are incredibly expensive, but here's a little bit of perspective. It's budgeted at 3.7 now. Let's assume it's going to be around 5 billion in the future. July of last year, Toronto experienced 100 millimeters of rainfall about 6 hours. That flooding led to massive flooding across the city and other regions, costing $940 million of insured losses. So remember my rule of thumb, multiply insured losses by 3 to 4 times. Let's round up, say it was $1 billion. That's $3 to $4 billion of uninsured losses. So in a one-day period, a high precipitation event cost the city of Toronto $5 billion. 1 month later in Montreal, 150 millimeters of rain fell, 72,000 insurance claims went out. The winds could have been very different that day, and that rainstorm could have occurred again over Toronto, and another $5 billion could have occurred. So yes, these are very expensive infrastructure projects, but it is more cost effective to adapt and reduce risk and cost now rather than waiting for those longer term impacts, which you are going to ultimately have to pay out. Now, of all the different types of adaptation measures that can be implemented across communities, which one makes the most sense financially and to reduce impact? Next slide, please, and the last slide. So that's going to depend on the community itself. So what actions, what adaptation measures makes the most sense for my community? Well, across Canada, there are over 3,500 municipalities, and each one has their own needs and resources. And most don't have time, money, or expertise to allocate to these types of projects. And so what the Intact Centre did was we developed what's called a municipal flood checkup tool to support Canadian municipalities in better preparing for heavy rainfall, river, and coastal flooding. So basically, it's a self-assessment questionnaire. It's 50 questions taken from standards and guidelines developed by authoritative bodies, and we've all just taken all of that information and accumulated it into one tool. And basically, it's to assess potential flood hazards, so flood exposure, and implementations of actions to reduce risk. So what's the flood preparedness of that community? So any municipality of any size, small, medium, or large, can take the self-assessment to determine what infrastructure project or where there is risk in the system for them. Now, why is this important for our conversation today? Well, we now know that the physical risks of climate change and extreme weather, those are going to continue to evolve and impact individuals, communities, governments, and businesses across Canada. Among these events, we know flooding emerges as the most expensive. Its extensive effects, it includes damage to both public and private infrastructure, disruptions to business continuity, up and downstream supply chain impacts, decreased labor productivity, increased health and safety costs, loss of life, devaluation of homes, and obviously more. So these financial and social implications underscore the need for communities to not merely acknowledge the potential impacts of extreme weather, but ensure community safety and resilience by actively engaging risk reduction strategies. So, ladies and gentlemen, we know that the impacts of climate change and extreme weather will continue to shape our future. The reality is, we're not dedicating enough resources and attention to adaptation, and as a result, financial and social costs are going up. That's the bad news. The good news, Canada is really well positioned to take action. The groundwork has been laid. We've done the action. We don't need, or we've done the research. We don't need another working group to think about how to do these things. We have done that research. And how do we do that for our homes and communities? We've done that research. We just need to take action on the ground. So I recognize that building development, it's very complex. Without clear mandates and building codes, which take decades to update, builders won't adopt these initiatives. But as municipal engineers, understanding the risk and what cost-effective adaptation measures are available or what tools are available might actually help empower you to guide decision-making and advocate for better solutions. So we don't have to start from scratch, but we do have to start implementing these measures now to get risk out of the system. So I'm going to end my presentation there, but thank you all so much for your time. I'm a little bit over, so I apologize for that, but of course I welcome any questions.
Okay, thank you very much, Catherine. I've got two questions on the Q&A. One is, can Catherine share the report that documents the amount of uninsurable costs as a factor of insurable losses? Can you share that with me and I can circulate it around to
Like the graph?
the report that documents the amount of uninsurable costs as a factor of insurable losses?
Of course, yeah, that's no problem. So Insurance Bureau, it's not an Intact Center document. Insurance Bureau of Canada displays that information, but I'm happy to send that link. Yeah.
Okay. The presentation will be posted on the MEA website. I just got, will you share the presentation? It will be, it's being recorded and will be posted. Lisa's typing that out. Thanks, Lisa. Would Catherine recommend building retrofitting for fire resistance in the GTA? Is there mapping that shows areas of high risk?
I wouldn't, for the GTA, that's not, I believe, like if we're going to focus on anything, flooding and extreme heat are going to be your greatest risk in the GTA. That's not to say that Northern Ontario wouldn't be impacted. I think we're going to see in the future some very big losses in Northern Ontario. I really don't see wildfire being a big issue in the GTA. So I would say put your resources towards flood reduction measures and extreme heat reduction measures.
Okay, so I will possibly get Catherine in the Q&A there if you want to type the link to that report. That probably will be the best bet because it's an anonymous ask, so I don't have the answer. I don't have the name to send the link to, so yeah. And I think that's everything. As we noted before, this will be recorded and posted on the MEA website, and that's everything. I don't think there's any more. If anybody has any more questions, please feel free.
I don't type answer. Do you know what? I'm sorry. I think I deleted one of the questions, but hold on. I'll go back here.
Oh, I have the person that posted the first question, so I can share it with her if you send me the link.
Yeah, and there we go. I just put the link into the question as well. But also,
Okay.
if it helps everyone, I'm happy to provide Kelly with, I went through a lot of different documents, a lot of resources. I'm happy to provide links for everyone. And Kelly, if you could post that, I'll just put it into a Word document if that helps.
Actually, that would be very good because we
Okay.
do have a resource page. If everybody wants to know, we have a resource page on the MEA website for climate change. So we can add that to our resource page. So that's
Perfect.
great. Yeah, that's great.
Give me a few days and I'll get all the links for you and just put it into a nice PDF for you.
Wonderful. I think this has been a fantastic presentation. There's another question here. What type of shingles are fire resistant?
So they're actually called Class A fire resistive shingles. Like there's actually, that is the title of them. So I don't know if what brands, we don't promote any given brand, but that is what you would refer to it as, a Class A fire resistive siding or roofing.
Wonderful. Any other questions? I don't see any more.
And please add me to LinkedIn if any of you have any questions. Again, I might not have the answer, but I probably know someone who does, and I'd be very happy to either direct you to our reports or any other resources that I have access to. So
Awesome. That's great. Thank you so very much. And
thank
we'll
you for
get,
having me.
yeah, and we'll get that page posted as soon as we can in the next couple weeks. And this will be recorded and posted. So I appreciate everybody coming out. It's been wonderful. Thank you, Catherine.
Thank you so much. Have a great day.
Yes, you too.